So how do we factor number 1? 4, and what else? 4x. And when you take out the 4x, what do you have left? 5x plus 6. Okay. 5 and 11. Okay, so since it's difference of squares, we got perfect. Okay. So what multiplies negative 18 adds to 7. 9, negative 2. Okay. But that was a typo, right? Because you meant k? Yeah. Okay. And it doesn't matter which order, you can switch them. So this order, or you can put the negative 2 first. I would mark you down just a smidge. Just a little bit. What if I called you Zaitlin instead of Caitlin? But is that your name? Well, there you go. I know. It's tricky. All right, next one. So take the function, find the x-intercept. So we're going to graph it on Desmos. The x-intercept is all the way over here at 32. So 32, 0 is what you should have for the x-intercept. What are the transformations? Okay, so reflect over the x-axis because of that negative in the front. What else did you say? Okay. Right 7, up 5. Okay. All right, now what do we have to do with this? Okay, so I'm taking k. I've got 2 places where the x is. I'm going to take out the x. Take out the x and stick a negative 4 in instead. And when you guys plugged in the negative 4, what did you get? Got 40. Okay. What do we have to do over here? Okay, so we're going to take g, so negative, take the x out, squared, and then minus 3, stick the 5m in for the x. Can I use a calculator on this one? No, not if you want to get the right answer. So the calculator will give you something, it'll just be wrong. You should not get just a number for this. You should get more than that. So what do we do? Is there something, can you distribute the negative? Yeah, so we want to make sure when it comes to a negative in the front or an exponent, we do the exponent first. So the exponent tells us to write it how many times? Twice. So I'm going to write 5m twice. Okay. And then what does this give us? Yeah, so when we multiply these, we just get 25m squared, and then it just happens to have a negative in front of it. So with this, there's not really anything to distribute because there's no plus or minus in here to have more than one thing that gets the negative. It's just one piece altogether that's going to happen to be negative. So negative, this is 25m squared with a minus 3 on the end. Can we put these two together? Nope, they're not like terms, so they're going to stay as 2 separate terms, and they are not going to be combined together. So 5 times 5 is 25, and then m times m is squared. Yeah. Okay, next one, we're taking function k. We got 2 x's here, so x squared minus 6 times x. And then in for the x, we are plugging p minus 1, p minus 1. Okay, and now what do? We can distribute the 6. So negative 6 times p, negative 6 times negative 1, what does that give us? Okay. Positive 6, right? Because you distributed it? That was a typo. We got it. You're good. And then what do we do with this part? P minus 1 squared. We do it what? We write it twice. And when you have parentheses written twice, what do you do with those parentheses? And we multiply them how? We FOIL them. Okay, so first. So first was p times p, which is p squared, okay. And then we got O for the outsides. So p times negative 1, which is negative p, okay. Then we've got I for insides. Negative 1 times p, negative p, okay. Then we've got L for last, which is positive 1, okay. And then we still got the negative 6p, and we still got the plus 6. Okay, so this leaves us with
negative 8p squared minus 8p plus 7.
perfect. Okay. What does this notation over here mean? Yeah, it wants us to subtract these, so it wants us to take f of x and subtract off h of x. That's what it's asking us to do. So we're going to go up and write down what f of x is. That's x plus 5. And subtract off what h of x is. That's 2x minus 9. Okay. So if I subtract these, what do I do next? Okay, distribute the negative sign. Negative 2x and plus 9. What about the part in the beginning? Just throw it in there. Nothing happens to the part in the beginning. You just write it down. Okay. So negative 2x plus 9. And then now what do we do? Combine like terms. Negative x plus 14. Marvelous. All right, let's get our names on those, get them turned in for some credit. Okay, so remind me, what's the very first thing we do when we're finding an inverse? Yeah, we're going to trade the x and y. So this one actually has a y in it. It doesn't have the other notation, so I actually get to trade the x and the y first. Okay, and then my goal is to get the y all by itself. So what's the first thing I can move over to the other side? I can subtract the 6. Okay, so I've got x minus 6 equals negative square root of y minus 1. And then what could I move to the other side? Yeah, I'm going to divide by the negative. I can get that to the other side by dividing by the negative. And you can divide by a negative, or you could divide by a negative 1. Both of those would accomplish the same thing. So I'll go ahead and put a negative 1 because that's what Caitlin had said. So dividing by the -1 will cancel these negatives out. What happens over here when you divide by the negative?
You're going to get negative x plus 6.
Okay, so the x becomes negative and the 6 becomes positive.
And then
Anyone know how to get rid of a square root sign?
you square it.
Yeah, you're going to square it. If you square it, you get rid of a square root sign. So we're going to take this side and we're going to put an exponent of 2. Square it. We're going to take this side and we're going to put an exponent of 2.
And then you're going to do what you call equals y minus 1, and then you're going to add 1.
So the squared and the square root, those cancel each other out. And we get y minus 1.
And then you add 1.
Mm-hmm.
Just add it so you can't do it in the first.
Mm-hmm. So we got -x plus 6 squared. The plus 1 happened after all of that. And so we got plus 1.
And don't you have to put the y equals
Yeah, the notation matches the beginning, but we have to say that it's an inverse. And how do we say that it's an inverse? We put the little -1 there. Let's try this example right underneath it. So this one doesn't have a y. Can you guys tell where the y is when you start?
It is the g of x.
Yeah.
It is, but
The g of x is just another way of saying y. So this is the y right here. It's just got a different name for this one. Okay. So how do we start the problem?
switch.
We switch the x and the y. Okay, so we're going to say x equals 5 square root y plus 2 minus 10.
And then you're going to add 2.
Okay, and then we're going to add the 10.
And then divide by 5. Divide by 5.
Someone who isn't Caitlin.
Divide by 5.
Divide by 5. What do we do? We square each side. Okay. Mm-hmm. So y equals all of this minus 2. So we want the notation to match the beginning. The beginning didn't say y, the beginning said g of x. And then we also want to make sure that they know it's not just g of x, it has to be an inverse. So how should we write our final answer? So g inverse of x. Okay, and then we can write the answer. Okay, so these are the ones that have the square roots in them. If we turn the page, we have the ones that have the cube roots in them. So let's try example 1 on this page. So with this one, what's our very first step? Swap the x and the y. And notice that when I write the radical here, that root, it has a little 3 in it. So it's a cube root. And my goal is to get the y by itself, and there's no number on the end this time, so I don't have something I can just add or subtract over to the other side when I get started. How am I going to get rid of this fraction? So normally I would divide, but dividing by fractions is tricky. Dividing by fractions can be difficult. So what's another way to get rid of a fraction that isn't dividing? You can multiply. So if I wanted to get rid of a 1/3, what could I multiply by to get rid of a 1/3? 3, yeah. So I'm going to multiply by a 3, but I also want to get rid of the negative sign. How do I get rid of the negative? I'm going to multiply by a -3. So it's going to cancel out the fraction, and it's going to cancel out the negative. So -1/3 times -3, those are going to cancel out. So it's not wrong to divide by a negative, it's just easier to multiply by a number than it is to divide by a negative. So -3 times x is what? -3x, okay. So -3x equals cube root y plus 6. And how do we get rid of a cube root? Yeah, so instead of raising it to an exponent of 2, we're going to raise it to an exponent of 3. So we're going to cube it. We're going to go over here. We're going to cube this side also. So the cube root and the cube, those cancel each other out. Wait until we finish. Okay, and then how do we get the y alone? Subtract the 6. So y equals Now, when I subtract the 6, can I subtract it from the negative 3x and put it inside the parentheses? No, because it happened after the parentheses. So it has to go after the parentheses when I write it down. So I'm going to say negative 3x to the third, and then minus 6 goes after the parentheses. So if I look at my notation, there's a y, so the notation matches. How do I show in the notation that my answer is an inverse? I put the little -1 in my answer to show, yep, that's an inverse. Okay, let's do example 4. So in example 4, where's the y? Where's the y in example 4? Anyone recognize where the y is? Is it the 3? Is this a y? It's where the p is. Okay, so it's not right there. The y is right here. So p of x is just another way of saying y. Okay? And so now what are we going to do? Swap them. So the x and the y have to trade first thing. Okay? And then what do? We add the 4. Okay. So we have x plus 4 equals 3 cube root y minus 7. What do? Divide by 3. And how do we get rid of a cube root? You're close. You have the right idea. But it's not a square root, it's a cube root. So what exponent should we use? Not a 1. A 3. So we're going to cube it. We're going to raise it to an exponent of 3. Perfect. And the cube and the cube root are going to cancel each other out. The cube and the cube root cancel each other out. So we've got x plus 4 over 3 cubed equals y minus 7. And then we're going to add the 7. And do we say that we're done when it looks like this? No. We got to fix it. What should it look like at the very end? What part is off? Needs a -1. So if it says y -1, does that make it right? It's not quite right. It's very, very close, but it's not quite. So if we look at the original problem, it needs to have a p inverse of x instead of a y inverse. So I'm going to go back here and say, okay, my final answer should actually say p inverse of x, not y inverse. I have to make sure that my notation at the end matches the notation of the original problem. Okay. We did less examples this time. How do your brains feel, even though we did less examples? It's very repetitive. It's the same as what we've been doing. Is it in there, in your brains? Yes. I'll help you find it in a little bit. Okay. You guys are okay with this? Yes? Okay. I'm going to go ahead and print. I printed these already, but they didn't format very well, so I'm going to reprint these for you guys, and then that's what we're going to work on for the last 20 minutes or so.